The moment. Is it going to work? I think it's working. It's working. Hi, Chris. How are you?
I'm good. How are you, Bill?
Good. Today we have Chris Denney with us. Ben couldn't be with us today, but Chris is with us from Worthington Assembly, and we're going to talk about all things dealing with assembly, which includes what, Chris? Somebody comes to you, and they have a great idea. They want to build a product. I assume you've had people approach you and say, we want to build this, right?
Yeah.
So somebody comes to you. How does it start? How's that conversation start? How do you start educating the customer?
Usually I tell them just go listen to the podcast.
We couldn't do that 20 years ago.
I know. Modern miracles. No, so like a lot of times I have to ask them a few questions first,
Sure.
right? Because it's
more
like,
than
okay,
they ask you. Yeah.
I can't believe how many times people have approached us and they've gone like, hey, I've got this great idea for this product, blah, blah, blah. It's like, that's awesome. That how can we help? And they're like, well, here's my idea. Can you build it? And they're like, well, do you have any files? Do you have do you have Gerber data? Do you have a bill of materials? Do you have any? No, what's that? Oh boy, you're talking to the wrong guy.
Right. Right.
You need to talk to an engineering firm, so we actually do have a lot of those kinds of conversations, and we'll connect them with engineering firms and stuff. But more often than not, the people that contact us, they're dyed in the wool, dyed. What is it? Am I using that phrase right? Anyway, lots of experience in getting circuit boards assembled before, whether or not it was a different company or they're unhappy with their current supplier, or they were building it themselves, right?
So a lot of people or something. Yeah.
A lot of people were just buying bare boards from your PCB ways, your Osh Parks, I think even DigiKey has a bare board supply now, right?
Mm.
And they were just hand assembling it, and actually we actually have a customer who he makes an open source sprinkler controller.
Okay.
So for your home sprinkler system, and he was building all of these himself, and then he would hire like college students that just needed some, pizza and beer money, and have them assemble them for him, and then it just got too much, and he had to.
Right.
And so a lot of times that's how people come to us, is they were trying to do it themselves for a while, and then they come to us. So that's usually it. We'd have to have that pre-qualifying conversation, or you go, well, I need 10,000 of these a week, and you're like, you got to go to China. There's no, right. I can't help you there,
Right.
Unless your thing costs an exorbitant amount of money, and you can afford a domestic shop to build it for you.
Right.
So you got to kind of be in that sweet spot of needing just one board, or needing 10,000 a year, maybe. We could probably do. It depends on the design of the product, but. So you got to make sure it fits that sweet spot, because we're a small company. I think we're only like, I think Worthington is like 35 or 36 people. We hire people move away. It's hard to keep track, but it's somewhere around 40 or just a little under 40 people. So you can't, no matter how talented and all the automation in the world, we can't build 10,000 of something in a week.
Right. Right.
Yeah. So you have that whole conversation, and then honestly, it's like, yeah, okay. So you're using Altium, you're using Eagle. What's your tool du jour?
Right. Right.
Here's how you export Gerber data. Give us that. Give us your XY data. This is the one that everybody always gets caught up on, is the XY data, because nobody typically knows what it is. Yeah, because they because if you're just ordering your boards from Osh Park, you don't need XY data. You just put it on your bench and you just start assembling it. I know where R1 goes. U3, it's right here.
I think
I don't, and my robots don't either. So that's our XY data. It's just literally just an XY plot coordinate text file that just tells us.
and it's got rotational data in there too.
Right, rotational data. That's the super cool thing about rotational data. It is almost entirely useless, and that's
that's been my experience, because somebody has to sit there and look at how it comes out of the reel. Correct me if I'm wrong. But no matter how I said pin 1 is, somebody looks and says, pin 1 comes out of here, and when it comes out of this reel, the way our thing works, we have to rotate it 180 to make pin 1.
It all starts with the manufacturer of the pick and place equipment. So, for example, Fuji, which is probably the largest pick and place manufacturer in the world, I believe they are the largest. I think they sell more machines than anybody else. They, they supply your Foxcons and your Toyotas and Fords of the world. They basically say whatever way it comes out of the tape or the tube is 0 degrees. So you have to kind of you have to program, say an SO8, right? One of the most common types of chips. You have to you have to have different programs. You have to have different SO8s for different packaging styles, because in a tube it comes out this way, and in a tape it comes out this way, and you have to figure all that kind of stuff out with Fuji. Other manufacturers will just say, no. If it's an SOIC, this is 0 degrees. When it's lined up like this is 0 degrees. And then it's there's no agreement, right? There is actually a standard. There is an IPC standard for what is 0 supposed to be, but none of the pick and place manufacturers follow it. Very few of the EDA tools follow it. I think Altium does try to follow it actually pretty closely. And so you just get a whole mess. What the rotational data is actually good for in that XY file is relative orientation. So when you have an 0402 and you have one wrong, well, they're all going to be wrong. So you can just say, okay, all of these parts rotate 90 degrees, and then, so at least you have some sort of relative orientation, and you can, but you always have to, we have to spend on every job. I mean, it could be literally half an hour just fixing rotations, not fixing necessarily, but getting the rotations lined up the way they should be. You usually do that at a computer station, though. You're not, by the time it gets to the machine, that's all long. It's all set.
Okay. So it's not like somebody had to crack open a tube and go, they're coming out with the cathode to the left or something.
Well, no. So it depends on your machine, right? So sometimes that will happen, but yeah,
that's been my experience.
Yeah, you should anticipate it. So, for example, an 0603 LED is going to come out of a tape, and just about, not every, but I would say 99 out of 100, and that's the freaky part, is that 1 out of 100. They're all oriented the exact same way, but every now and then they're oriented differently, and that has bit us so many times. We will literally pull an LED out of a tape, hit it with a probe, an LED tester, look at it to see it light up, and we go, okay, that's cathode, and we tape that to a piece of paper.
Been there, done that. Yes. Yeah. And I just caught it on a design in the last year where I go, oh well, I would have screwed up every LED at least. It's
yeah. We definitely have. We had this. I don't know what the heck these boards do. There's like this circular array of LEDs, and one's red, one's yellow, and one is I think green. And the part number difference on them is R, Y, and G. So when you look at it, you pick it up and you go, oh, this is the part I'm looking for. But if you didn't notice it said R and you needed a Y, you load that wrong. We've emptied full reels of LEDs, just all wrong.
Wow. Yeah.
That is not a happy day. That is not a happy day at all.
No. So yeah, I used to call it like playing with a fire hose. It's fine till there's a leak, and then everything gets wet. It's when you're in mass production, a small mistake multiplies quick, or in production, I should say.
I noticed one guy in your chat room. Forgive me if I'm pronouncing his name wrong, but I'm going to call him. I'm going to call him Yari. He said he had a TQFP mounted 90 degrees wrong. I would be so embarrassed if I did that. It happens, but it's so embarrassing when that happens.
So 15 years
and then the blue smoke got let out.
15 years ago on the TQFP 64s, we would argue about whether it was corner pin 1 or center of the top pin 1. And it's a simple thing until you get real used to one and you forget to check it on your next design.
Yes, so the PLCCs do that all the time. Yep.
Yes.
Yep. And different manufacturers choose different
to be a standard. You had to go check and design knowing where your pin 1 was.
Yeah. And then so it used to be you could trust TI always did it this way, NXP always did it this way. Like you could trust, but then they're like the T2000. They all start like merging into each other, and so you
Right.
don't know that actually this was microchip before they got bought by NXP, and now it's actually so you can't now you can't go by the manufacturer either.
Right. 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 Yeah, I
Oh,
was, I got out of the business sort of for a while. I owned an internet service provider and whatnot. And then when I got back into it, I'm like, what happened to National? Where'd National go? And they
yeah,
had been
yeah.
bought by, and I think all my favorite companies have since been bought. So now,
Like I
if
said,
some,
it's like the telephone companies. Like there was AT&T that exploded, and now it's becoming all AT&T again.
right,
They're
right.
all just merging into each other.
Only now it's wireless. Yeah. Let's see. I'm looking for somebody asked a question here. We at work we got oh, how do you fix that? Well, before we get into things, then I
Tell
will
you how
ask,
to
how do
fix
you
it.
fix the 90? You have to rework it, right? You have to
Well,
remove the
yeah,
part.
that's how you physically fix it. Yeah,
Yeah,
physically you just take, you find a really, really skilled operator and have them heat it up and pick it up and rotate it and clean up the
right.
pads. And actually, what we will often do is if because we'll actually have like maybe somebody like dropped a tray, right? And they have to reload the tray by hand, and that maybe they got one wrong. So it does happen. Like it totally does happen. But
Right,
our AOI would catch something like that. So it gets
right.
into inspection and goes to a rework person. What a lot of times we'll do, because we have fancy equipment, is we'll hot air remove it, but then we'll actually it depends on the application, depends on the you know whether or not the board can be reflowed multiple times and the chips can be reflowed multiple times and if it has through hole on it. But a lot of times we'll just take that QFP off, put some tacky flux back on the board, reflow the whole thing again. It's much easier
Okay.
than trying to hand solder a QFP.
Okay. So the board can go through reflow again and not critically upset the existing solder joints.
Yes, that's right. Yeah, usually, normally, what you're upsetting is sort of like the longevity or reliability of the product. So, like, I know that there's like aluminum
That's why I said
capacitors don't.
critically. Yeah. Yeah.
Yeah, yeah. There's certain types of components that don't want to be reflowed
Some
too many
vendor
times.
and some vendors wouldn't want you to do that to your board, and other times they go, does it still work? And you go, yeah, and they go, that's
Yeah,
fine.
yeah. So
Yeah.
usually we just disclose that. We just say, hey, we had to, these got reflowed an extra time, and usually customers are like, yep, no problem, or they'll just those like, yeah, I can use that on my workbench. We won't ship that one or something
Right,
like that.
right.
Yeah,
So here in my lab, to remove a big part, I've got the hot air adapter. I just looked for it but didn't see it real quick. So I've got the hot air hot air gun, whatever you want to call it, and it's got to be. But what I use for the big stuff is I have an IR infrared
yeah,
desoldering thing. I just love that thing, but then I
it's
stumble
cool, right?
around the house the rest of the day because I'm blind from using it. So you
I
have to
can't
wear
recommend
sunglasses.
enough. I cannot recommend enough a bottom side heater of
Heater.
some type. Yeah,
I've got a
like
preheater, ceramic preheater.
yeah,
Yep, yep.
you don't have to get it scalding hot, but you just want to, just get the turkey warm before you go and try to
Well,
deep
it
fry it or something.
stresses everything less to heat it more.
Yeah,
Correct me if I'm wrong on that, but preheating your assembly, right? Even you think, oh, I'm heating it up, heat's bad. Well, no, it's preheating it so when you do go to remove a component, it's less of a shock, less of a
that's right.
jump. You're only
Yeah,
going that last 50 degrees or whatnot. And the components around it say our solder joints are good. Wow, but you took that part out.
yeah.
That's the way
Oh
I
yeah,
look.
yeah. We have it's always fun when you're having to rework a QFP or something. There's like a bunch of little 0402s or 0201s sitting around
And
all
they all.
around it. Yeah, they
I've,
all. Whew.
I've never blown away an 0402 and wondered what the heck happened to it. Yeah, it's a
Yeah,
well,
yeah. You because that's it might get stuck to something else, so you really got to look at that
yeah.
thing really thoroughly. Yeah.
Well, the 0201s are an inhalation hazard. You don't want to accidentally inhale those things. They're so small.
So
I
I
I
went
won't work
to
with 0201s.
I went to a yeah. If you don't have to, don't
No, no.
don't work with 0201s. I went to a pick and place, the same one I was telling you about earlier. Fuji. They're out. Their U.S. headquarters is out in north of Chicago, And we were talking about the latest chips and everything, because basically Fuji and your Muratas of the world and TDK and everybody, they all work together to come up with, here's the chip, here's the packaging, how do we place it, do we have the accuracy, do we have the vision? Like, they have to work together as they make these things smaller and smaller. So they have reels of these things. And they call them the metric 0201, because it's, you know, it's like, once you start saying 0201 and then you go 01 to 05, it's like, how many more, like, you know, zeros do you want to throw in front of this? So they just switched to using metric for everything. So they call it metric 0201. But these things, we held it under our microscope, and the chips would fit into the little the valleys in our fingerprint.
Wow.
It was insane.
That's
and
the
like
size
each one of
the
them,
globules in the solder paste.
yeah, well, not the solder paste for these. You need to use type 6,
Well,
I believe.
that's what I was going to ask. So then you have to have a different solder paste then, right?
Yeah, exactly.
Wow.
Yep.
Wow.
The crazy thing about these chips, though, I think they're like 50 or 60 cents a piece now, down from a couple dollars early on. So like a reel of these, because I think a reel holds 20,000 of them, one reel. So you're literally like a $10,000-$15,000 reel of 0.1 microphone, 0.1 mic capacitors. It's like,
wow.
Oh my God.
Wow.
Yeah.
So if somebody comes to you, like let's say I have a project, of course there's different steps in a project, right? And the first step's prototyping. And a lot of people, my lab, I can prototype, right? Down to certain sizes and certain, I do have double-sided, and we'll talk double-sided here in a second.
Sure.
But I don't have a lot of experience doing it. So, but you can also assist in prototyping, I'm assuming. If somebody says, I do have my Gerbers, I am an engineer, or I've been hired an engineering firm, but I only need 3 to 5. You can handle that, I assume.
That's kind of our bread and butter.
Is that your sweet spot?
Yeah. We're a small company, but we probably do like close to 10 unique jobs a day, right? And
wow. Okay.
That's not by building thousands of the same thing. That's by building 3 of this and 10 of that and 20 of those. You know, that's really the bread and butter of the U.S. contract manufacturing business in general, right? There's just no room left in the volume, or you're in automotive and you've got, you know, more letters after your name than a doctor, you know what I mean? Because they got all these crazy certifications, or a defense, right? But everything else is, you know, we're not in defense, we're not in automotive, so everything else is it's prototyping, yeah. And then also, like, there's plenty of products. Like, we have a customer. I'm a huge anybody who's listened to the show, they know I'm a huge motorsport fan, but we have a customer that makes the sensors that measure the temperature of race car tires as they're going around the track, and they can monitor it from the pit box.
Right.
Well, there's only so many race cars in the world. You know what I mean? Like, you don't have to make tens of thousands of these things. Like, a couple thousand, you know, every couple months is fine. And so we'll have plenty of those kinds of things too, where, yeah, we did 10 for him, we did 20 for him, and now he needs 1,000 a month. And yeah, that's still like sort of a good sweet spot for things, you know?
Okay. So if I come to you and I only need 3 boards, so I'm starting at the beginning of time here, and I only need 3 to 5 boards, as I said, and I have my Gerbers, I have a pick and place file, which is this file we've been talking about with the XY
file,
and
CAD
stuff.
file, yeah.
Yeah. Now, how do you do 3 to 5? Will you sometimes hand assemble, or do you use an assist to assemble, or will you use a small pick and place machine or the production pick and place machine?
So we will use the production machines. We have a smaller line that uses lower speed, older machines, right?
Okay.
Because all your capital costs are amortized over that. You know, it's like, just if you keep the thing running, it's just making money, right? It's not like the big $1 million line that thing has to thing has to keep running,
right?
But yeah, I mean, the truth is, it's all about, in U.S. manufacturing, in this kind of a business, it's all about, like, being as efficient and having as tight a process as possible to get it to the point where you can financially afford to pay us to build 5 pieces. Right? Because if we were an automotive supplier, if we were a defense supplier, you know, you want 5 pieces? Sure, it's gonna be $5,000.
It's a day
You know?
setup. Yeah.
Yeah, because all we know how to do is take 24 hours to change over our line because we only do it every month.
Right.
So
And
we
it's a
have
very
to.
laborious process of making sure the
Yeah.
reels.
Yeah. But no, we do. So we set up the reels, we set up the feeders, we do all that. But what we've done is we've just structured our process, and we've structured our factory to do that as efficiently as possible. Nobody's hunting for a feeders. Nobody's, where do I find this? Where do I find that? Like everything you need is exactly where it is when you need it. It's all lean manufacturing. It's all this, the techniques that Toyota developed in the 60s and 70s, and it's all just about getting the waste out of everything. That's the only way you can afford to pay a professional shop to use professional equipment to build stuff. And the truth is, very few of the prototypes we build anymore are even possible to hand assemble. Like they are. Don't get me wrong.
I totally get you.
Anything.
Yeah. Because I look for shops like yours when I go, I can't hand assemble this.
It's just like everything is leadless. There's a BGA on everything. There's some kind of radio module on everything. There's some kind of QFN, WLCSPs, 0201. Like
you can't even see the leads because they're underneath it these days. Even small little things have little BGAs. Yeah. And if I can't see the lead, I can't, even though I'm using an oven myself, that's where I draw the line. So, now, see, that's a big difference for me, though. If I'm coming to you and I say, hey, I'm only making 3 of these, and I like to buy my parts myself, I have to take into account that you're actually still going to use an automatic pick and place, which means the parts need to have leaders and stuff. Right? You'd rather buy the parts than have the customer buy them?
Yes, for the love of God, please let me buy the parts.
That's where I was going. That's where I was going.
Yeah. So we, I see Andre here mention that there are manual pick and place machines. We actually still have a manual pick and place machine. We just found it's just not useful.
Yeah.
Because you just can't get the accuracy. You just can't nothing we build is 0603 and larger. It's all tiny stuff. You just can't do that with a manual, but they do exist. But no, so depending on the machines, right? So certain machines need more of a leader than others. And so we know this, and we know that our current equipment needs a longer leader. And so we have to buy all this stuff for attrition, and we know we have, different pick problems on some of our older machines. So we end up having to buy a significant amount of attrition. But you need 5 pieces, and it's a 0.1 microfarad capacitor. I'm gonna probably buy almost a full. I'm gonna buy 500. I might only need 50, but 500 is gonna cost me $2.
Right.
Yeah.
So that's kind of the question is you would have to go out and buy a reel or a digi-reel, or do you guys buy digi-reels and mouser reels, or do you only deal with the full reel? A digi-reel, for those that don't know, is you can have DigiKey go ahead and put something on a reel for $7, and they'll put a leader and a tail on it. Is that acceptable?
That's a big cap. That is a big.
That's a big cap.
How many farads is that cap?
3,300.
Yeah, that's a big cap, man.
But you wouldn't want to buy a reel like this to make 3. That's kind of my point, right?
Yeah, we find that we are more efficient than $7 a part number. Right? Okay. So our costs are lower to manually handle that as cut tape in a bag than to buy, charge our customer $7 for DigiReel. Because a lot of times a job will have 100 lines. So, there's an extra $700.
Yeah.
And it's really
for 3 units.
It's not our time savings by getting the DigiReel is not very significant. We're probably maybe saving 15 seconds. It's no, I'm not going to bother for 15 seconds, $7,
Right. Andre just asked, so you have losses for the leaders, and absolutely, right? That's just part of the business.
Now the new equipment we bought is significantly less. So the new Fuji equipment we bought is significantly less. It can technically pick the very first part and the very last part out of cut tape. However, it's a little unrealistic. Like you're not going to do that every single time. So you can't just, I need 100.1 mics. I'm going to buy 100. No, you need at least 110
120
or
or something. Yeah.
Yeah, something like that.
Right.
Because
right.
you'll get like a clogged nozzle, or you'll get and again, new equipment is better at detecting clogged nozzles and things like that. But you parts will get lost. These things are cavernous. It just we have a little electronic component vacuum that we clean these machines with, and it's getting pretty full. You just go and yeah, though it's a little embarrassing to admit, but it's true. In any shop you go to, you'll see just it's just the nature of the assembly process.
Right.
You have a vision system that looks up at a part, and okay, we're talking 0.3 millimeter pitch, balls on a CSP. You get a piece of dust on there on a vision system, because I don't know what the hell that is. Reject. It's crazy.
Right. So if somebody so you use the same process then. If I come to you at all 3 stages of my production, for example, I come to you for prototype and then some kind of small pre-production run and then like a step in production run or some, you would use the same process for 3 and then 20 and then 100?
Almost. We'll use almost the same equipment. All of the like production equipment we're going to use a full stencil printer, premium solder paste, proper reflow, pick and place, everything. That's all not going to change. When it comes to inspection, we're going to handle a little bit differently, because to program a 3D AOI, and if listeners aren't familiar, automated optical inspection, it's like a camera with lighting, and it'll verify that we did what we were supposed to do.
Right.
To program that, even let's say I was to program that for something like an Arduino, right? Probably like 2 hours to program the machine, and like to really nail it, maybe 3. Like we could get the ball rolling at 2 hours, and then to spend another half an hour to an hour refining it for a product like an Arduino. But I don't want to charge a customer 3 hours for something that I'm only building 3 pieces of.
Right.
Like it's not worth it. So
yeah,
we'll use a simple AOI machine to catch kind of the macro big picture. What did we really screw up?
Missing parts, that kind of.
Yeah. Okay. Rely more on our visual inspection with microscopes to verify everything's correct. So that's about the biggest deviation. Maybe if there's through hole, we might hand solder more of the through hole versus automated soldering. But
post solder assembly, that's a big area where it differs whether you're in mass or just hand it, or even the customer may sometimes say, I'll add the nuts and bolt, the post solder assembly.
Yeah, that's actually super common. It's super common for the customer to say, DNP, do not populate any through hole. I just need you to do the surface mount. That's a really common thing we see, because through hole is just, there's no way to slice it. It's just expensive. Like unless you're doing like tens of thousands where you can automate the crap out of it. It's just, you got to manually populate every part.
Right.
It's just, it just takes a long time. And
now,
it's like, we don't hire people at minimum wage. We're hiring people and paying them what we can.
Right.
It's just not, it's not a cheap process.
What, I can't even remember what we call the old insertion machines. The name was actually different.
VCD.
Yeah.
VCD was the common term for the axial, and then there was RXD for radial insertion machines. Yeah, I actually used to work for the company that manufactured those.
Like Universal or somebody?
Yes, Universal Instruments. Yep, they're out of Binghamton,
the Commodore 128. We laid that out. The Commodore 64 had been laid out for pan insert, and I remember the heads come in from one direction, right?
Yeah. And I worked for Panasonic for a little while too.
Did you? Oh, okay.
Yeah.
So we said on the 128, said we want to assemble this both in America and overseas. So the 128 was what, for us, the first board we ever knew of that was insertable by both American and Japanese heads. So and what we would do is 2 engineers would cluster around the table, and one would act like an American insertion and the other guy would act like, and we would look at every component, make sure it was clearance and order of stuffing and everything. So
that's so cool.
Yeah. Yeah. We were
That
pretty
reminds
proud
me
of
of
that.
like, we have customers that a lot of times they'll have trouble sourcing like the exact voltage regulator they want. And so they'll lay out like an SOT 223
Yeah.
and oh gosh,
A
like a
TO220.
D-pack or something. And
Yeah.
they'll put them like right
Deepak.
next to each other, right inside of each other. So, well, if I can only get this one today, I can only get that one today, and you can still build it, you know?
Right.
Yeah,
Right.
those old Universal machines were super cool. That was the first machine I didn't even have a license. I must have been 16, maybe 15. I can't remember how old I was. It was the first machine I ever ran. I went to work for my buddy's father. He had
Right.
this small little contract manufacturer building. They were building zone control boards for like your HVAC to like open and close dampers. And anyway, and I was running, and it kept jamming up. And the guy who was training me was like leaving, and like he didn't like give a crap. So he's like, yeah, if it does this, just hit the reset button and it just keeps stuffing the same part. I'm like, I don't think this is working. He's like, just try it a couple times.
Uh,
Yeah, we had all
Alan
kinds of
Wolkin
issues.
just said in our comments they used to call their machine the pick and throw machine.
Mm-hmm.
For
Yeah. Well, the Universal, yeah. Universal had bad SMT machines for a long time. They're good now. The new ones are good, but early on they had some clunkers.
Yeah,
You had
he's saying from the 80s. Yeah.
Yeah. So that was probably pre GSM. When they released the GSM, it was everybody wanted a GSM, and what everybody was doing is they were putting the high speed chip shooters, like your Fuji CP6s and your Hitachis and all these, like they had these super high speed. I mean, you want to like, not to pull people away from your YouTube chat, but if you want to look up YouTube, type in Fuji FUJI space CP6. Those machines, watching those things run, they're slow now by comparison to the new machines, but they were just so cool to watch because they were just like, they looked like a Gatling gun just stood up and just
Right.
spitting parts onto a board. But those were super high speed, and then they would put the Universal GSM after it to do all your QFPs and BGAs and all your weird stuff. And then the CP6s, they would just slam parts down super fast. And then Universal had a partnership with Sanyo, and so they would rebrand the Sanyo, and the Sanyo was not. It was no Fuji. No.
Right.
So I could talk about this stuff forever. The equipment is what kept me in this industry. Like, I went to engineering school, and I was like, that's cool, but I love these machines, and I want to keep working with these machines.
And I'm from the days when every company that did assembly, except for like the Commodores of the world, right, had a big room with about 15 to 30 people in it, and they were called the assemblers. And that's what they did. They sat there and did the through hole assembly. And that's how I worked at Pennsylvania Scale, Lionville Manufacturing, all these different places. The room even looked the same. Rows, workbenches full of people sitting there doing manual assembly. And that's how you built stuff, in the late 70s and early 80s. I should say that's what I saw how it was being built.
Okay. Was it entirely by hand, or was it machine assisted at all?
No, we were doing entirely by hand in like 1,000 a year quantities for different. It was instrumentation, but we just didn't have a place to go to. It was hand tape. There wasn't the support for auto insertion didn't exist at the design, let alone at the production level at our place. And yet we were in a small place. We made a lot of digital scales. We did it for the post office.
I loved getting the hand taped boards.
Yeah.
Because we still do see that. It's rare, super rare, but we will see somebody with a hand taped board. We haven't seen one in probably 3 or 4 years.
One of our viewers, Frank Buss, has a CAD program that he paid for it from out of Russia somewhere. Yes, Russia or Ukraine or something.
Nice.
That has a hand tape like feature. So when he's done laying it out, it looks like
it's got nice loops and
and a little waviness in the parallel lines and stuff. And he said he loves it. So he did that on purpose.
That software engineer loved his job. You know what I mean? Like to take the time to develop like a fake tape out. Like that is pretty
fake
cool.
Old way of doing things.
I love getting the taped out ones because I'll show like, because we have a lot of guys who are like 20, 21 years old, you know, and I'll show them and I'll like, check out this board. And they're like, whoa, you know, that's crazy looking. And I'm like, this was done by hand. What do you mean done by hand?
Right.
It
You
always
use
blows
the
their mind.
computer
You know?
in both hands? No,
Yeah.
no computer. Right.
Yeah. And I'll show them how they would like put the tape and take the razor and
Right.
that's crazy, you know. It is pretty cool.
I had forgotten that we didn't do it at 1-to-1. In my mind, I was thinking, oh, we hand taped, but I think we hand taped it 2-to-1 now that I'm 2-to-1 or 4-to-1 now that I'm looking back in time. So
never did any of.
Yeah, I know.
I know how it's done. I've seen it done, but I have no idea. Yeah.
One of my favorite stories is the guy we brought in at Commodore to do our CAD. We started at hand tape. When I joined Commodore, we were still hand taping. At the place I worked before then, which a bunch of us left and went to Commodore, we were still hand taping. I just remember the day I leaned up from the board and I had 3 of the guy's tapes stuck to my arm. And he looks at me like this. He's like, it's time to kill you now. Yeah. And I'm like, I have to go over here. Yeah. So
I gotta tell you though, like, I love doing PCB layout. I find it like it must tickle that same part of the brain that likes like building IKEA furniture, or Legos, or something. Like it's just this sort of like I don't know. It's like a really fun puzzle to solve. Like, how am I gonna get all this to fit, and how am I gonna get all the signals where I need them? And I like the first 90%. I hate the last 10%.
I was going to say, now see, I'm the opposite. I like to stand behind the guy that's really, really good at doing layout and answer his questions. I like to say, no, ground over here. I can see the radiation coming off. But for me to sit down and do a BGA myself, I'm a blathering idiot by the end of the day.
I love it. I don't know why I like it so much.
But I'll troubleshoot a ground loop, and I love.
See that I can't. No, that I don't want to do. I'm not in.
Yeah, no. I like.
We'd make a good team then.
Yeah.
I'll make a giant mess that looks nice, and then you'll fix all the problems. Yeah,
and then I'll own the problems. That's how it works. Yeah.
We actually had this. We had this one customer recently. They did they make high power amplifiers for like television broadcasting and radio broadcasting and stuff. And there's like scientific instruments. Basically, they make super high power amplifiers is what they do, and whatever you want to use them for, you use them. We're talking like they fit in a room amplifier. Anyway, they had this one board that, they had, I think it would be much more powerful than a concert amplifier. Anyway, but they had this they had this board, this crazy. Basically, it was just a load. It was just to put a load on the system when there wasn't an actual load or something like that. Like when, for whatever reason, they couldn't actually throttle down. I don't know. Anyway,
thyristor's need load sometimes. Yeah.
Yeah. So they were having all kinds of issues, and they're like, I have no continuity from my top layer to my bottom layer. And I'm looking at it, I'm going, well, your bottom layer is nothing but ground. And your top layer is practically nothing but ground, and you've got vias everywhere. I don't understand what the problem is. There was this crazy thing happening where because they were using this like this material, I think they call it Taconic. I don't know if the manufacturer is Taconic or the product is called Taconic. It's some kind of RF crazy. But the fabricator, because we don't fabricate, we just do the assembly.
Right.
But we hire and we work really closely with the fabricator. Like we talk to our fabricators every single day. Anyway, they were getting like micro voiding on the walls of the vias, like these tiny little, imagine like a Swiss cheese, like it is cheese, right? I got a wheel of cheese here, but there's all kinds of tiny little holes in it. And so it was creating like a capacitor circuit almost. And, that was talk about figuring out an issue with ground. I was like, I mean, you've got hundreds of vias and you've nothing but ground on this whole board. What do you mean you have a problem? It was crazy.
So, and an insidious version of that would be only some of them were messing up at high frequencies, but you're saying that you just didn't have continuity between one side and the other with hundreds
Not
of vias?
Sufficient. It wasn't sufficient.
Or it was crappy. Okay.
Yeah, it was crappy continuity. Yeah, because they would tell us that we have no continuity and they send it back to us, and we're not
And DC
electrical
had
test technician.
continuity, but
Yeah, we're
not.
like multimeter, fluke meter. Yeah, it's got continuity.
Right.
But our board fab was smart enough to go, no, send those back to us. We got to cross section them, and then they found the issue. So yeah,
What was
that was painful because they were like $7,000 or $8,000 boards. They were not cheap.
Yeah. Well, see, and people are so used to thinking of the cost of the board being the parts that go on it. But if you get a router board that has to supply 100 amps at 1 volt to one part, and there's 30 of those parts, that's an expensive board.
Yeah, for sure. For sure.
And we think of like switches like we use for networking, right? We think, oh, I'm a gig. No, wait a minute. Let's think about that. That's a gigahertz. That's a radio frequency times every single port. And all that has to go somewhere. And yeah, the math adds up fast, the cost of those boards. And yeah, I've made mistakes. I've made $250,000 mistakes before, but not lately. Well, mine was a chip, but yeah,
I've made like $10,000 mistakes. That was sufficient enough for me.
Right.
Somebody in your chat, Andre, is asking what popcorning is. We actually just had an episode of our podcast talking about this effect of where you put a circuit board into a reflow oven and it sounds like you put popcorn in the microwave.
That's humidity, right?
That's mostly well, it's humidity, but it's also poor process control.
Right. Exactly.
Yeah. So like at a basic level, certain types of materials are like plastic is not completely impervious to allowing air through it and allow moisture and vapor through
or
it.
Epoxy.
And so an epoxy. So like moisture and humidity will get trapped inside the chips. And then when they go through reflow oven, well above the boiling point of water, they, and just thousands of them can do that. So, but we have process control to make sure that like, if it's a moisture sensitive device, it's never exposed to air for very long. Like it'll be in a dry cabinet, less than 5 degrees.
I was going to ask you if you have dry storage. Yeah.
Or it'll be sealed. So a lot of times like dry storage is very expensive. Like you're talking like a cabinet, if you wanted to build your kitchen, a typical American kitchen with dry cabinets, you'd be looking at tens of thousands of dollars worth of dry cabinets. They're so expensive. So a lot of times, like if we're done with something, we don't think we're going to use it anytime soon. We reseal it, put it in a fresh ESD bag or a moisture barrier bag, throw a desiccant in it, reseal it, date and time of when it was opened and closed, so we know how long it was exposed. Like you got to have good process control in order to prevent popcorning.
Right. Yeah. If I open this bag, which I'm not going to do because that'd be poor process control on my part. There's a humidity indicator in there and a desiccant. You can hear it all rattling around. Yeah. So for people at home, they generally don't have to worry about dry storage unless you're going to keep a part for 90 days or more. And there's some parts that they show up like wrapped so heavily you wonder what the manufacturer knows that you don't about the humidity. I built a dry storage. You can at home. I have one of those just big plastic containers with a very tight sealing lid and a lot of desiccant in it. And I have a humidity indicator. I have a box of humidity indicators in there and I just pull one out and leave it laying. So I do my own dry storage for long-term stuff. And
so the dry storage I'm talking about is active. It's actively drying the air and actively pulling the humidity out.
And mine's just a storage. And inevitably, when I can't find a part in my lab, it means I stuck it in dry storage and forgot about it. It's kind of how it goes.
Yep. So believe it or not, parts can get lost in dry storage in our cabinets too. It's funny. It's because it's a weird storage location. It's not like our normal storage location. It's like this weird thing, and sometimes it's sealed and it doesn't go back into dry storage. And moisture sensitive devices they're always a lot of fun. But the if you live in New Mexico, you could probably leave like moisture sensitivity level like 4 and 5 out for days, and like you're not gonna have a problem. But if you live in like Miami
or Jersey,
don't leave that. What actually? Do you live in Jersey?
I do.
Yeah, whereabouts? Because I'm from New Jersey originally. Where do you live?
Oh, okay. I'm
What town?
down in
You
Gloucester
don't give away
County.
your address here.
Yeah, no, I'm in Gloucester County, so I'm
Gloucester
not
County.
too
Okay.
far. I'm down in southern Jersey in the
So
center.
I lived in Point Pleasant, which was like exit I think 98 on the Garden State Parkway. So I was like right in the middle there. I
Right.
loved it down there. That was a great
That's
spot.
the old joke too. It's I'm from Jersey. What? Oh yeah, what exit?
What
You
exit
know,
are you? Yeah, yeah.
I'm from
This
Joint
week
East.
in New Jersey residents, thank you everybody for tuning in.
Yeah, right. Sorry about the humidity, but that's why we're talking about part
Yeah.
storage. It's so
I wanted to circle back just a little bit because you were
yeah,
asking
yeah,
about like the process of assembling things, and somebody had asked about how do you prevent a part from getting placed 90 degrees. We had this. I would be shocked if most of your listeners weren't already familiar with Chris Gamble and his Amp Hour
Chris. Yeah,
podcast.
yeah.
And then he had helped to organize KaiCon,
Right.
had the past subsequent, and in 2019 I gave a talk there, and because I was invited to give a talk, and I wanted to talk about like my biggest pet peeves, so to speak, like what is it that really just throws a wrench in the gears to our process, like what
Right.
really grinds
What
things to a
stirs your
halt when we
pace?
try to do
Yeah.
things. And getting polarity right is something we spend so much time on. So
Yep.
like the more you can do, like if you're handing this off to somebody, you're like, here, build this. You just want to do everything you can to give them all the information they need. So like some software packages will have like a separate like assembly documentation export
Right. Right.
from Gerber, and it'll even be like in Gerber format, so you can like overlay it in your Gerber viewers and stuff. But like the old school,
Yeah.
I see
They
people
they
talk about
produce
Monmouth County.
assembly drawings and
Yes, those
isometric
kinds of things.
drawings built right into
Yes,
the software. Yeah.
yes. So those are great, but honestly, the like from a simplistic standpoint, like just I don't want to have to go look up this file. I don't want to have to flip through it. I just want to look at the board and have the answer. Just nail your silkscreen. Just
Yeah.
like pay attention to your silkscreen the way you pay attention to your copper. Like really care about it. Really, really care about it. Or just get rid of it all entirely and just force us to use the assembly drawing.
Oh,
Right? Like
interesting.
don't
Interesting.
don't half-ass it. Please just get
Don't
it
have
right.
nebulous dots that could or could not mean,
No.
and
So
use
we had
use a dot in other places. It's
right.
and
Right.
I'm
We
big,
had
if I can, I like to orient the components to be the same orientation if I can.
that's
In the
pretty
old days
sweet.
we
Yeah.
could.
We
These
love
days
that.
it's harder. Yeah.
Yeah, it's really hard to do that now. The other thing I like to do is I like to make pin 1 rectangular pad and all the rest kind of like an oblong or like a rounded rectangle.
Right. Right.
So the pin 1 stands out as, hey, this is the rectangle. This is the one. This is the pin 1. If I can't get it done with silkscreen, we had a customer recently who we actually have a lot of customers who use an asterisk to define pin 1. That's a super common thing. I think that's actually kind of like I think there's a lot of package libraries that come with KiCad that have an asterisk as their pin
Oh,
1
interesting.
in their library. Yeah, but anyway, but then we had this one customer recently who put an asterisk next to a diode, and then had that same asterisk like somewhere else on the board, and it was like D15. So it was supposed to be like a reference. Like he couldn't fit D15, but he could fit an asterisk next to D15, and then he put the little, the footnote over here,
Over
D15.
there. Yeah.
But we thought it was the anode band,
Polarity, right.
So we built all his boards wrong because I was like, oh no. I mean, we felt horrible, but he totally understood why we would make that mistake, and we, have since
Right.
corrected it. But yeah, weird stuff. You end up seeing some weird things like
Well,
that. But
you
silkscreen, silkscreen is used. It's a thing. Like don't think it's like a legacy thing. Like it is still used to this very day, and it's referenced. And even if you don't print it, right? Even if you don't want it on your actual board, still do it, because then we can pull it up in a Gerber viewer and we can see it all. You know,
Right.
we can overlay it on our population file because when we program a pick and place machine, we're creating these 2-dimensional files that represent all your components and how they fit, and we're verifying they fit your footprint, and we're verifying your footprint's correct and all that kind of stuff. And so we're looking at your silkscreen as we're building these things and making sure everything's oriented right. So having your silkscreen done well, even if you don't want it printed on your board, is also still really valuable. And you know, there's you know, some people don't know this, but there's actual rules about line thickness. Like certain shops can't get thicknesses as thin as you think they can. You know, just because copper can get down to 6 mil doesn't mean silkscreen can get down to 6 mil. You know?
Yeah, no, silkscreen is exactly what it says. It's the old screening process from. It's how you make T-shirts. You know,
it's literally there's still, and a lot of times, a lot of fabs are still literally by hand. Just
wow,
a lot of them, a shocking number of them. But more and more, they're jetting it. They have like a little dot jetter that they jet onto the board. Trouble with that is it's very slow, right? So you and it's going all over the board versus just one done. You know, so those jetting machines, but those jetting machines can get really small too. So they can get better detail on them than the screens can.
Well, you've hit on why I like to get into, you know, I could build my own boards, like prototype, even pre-production, but then I'm missing those chances to catch polarity problems when I'm only building 3, right? Or only build. So I like to get into production process as early as possible, so that when I do a pre-production run, we've already debugged together the anode and the cathode. Yeah. You know, that's my way of.
And it's nice to have that kind of a conversation, like to let us know, like, this is a pre-production run. There may be gotchas. Let me know about the gotchas. Like, we'll try to find them. You know, but you can't always catch everything. If we don't see a polarity indicator for a component, we pump the brakes on everything. Full stop. We need to know where these things go. We're still ordering parts and everything, but like, we can't build anything until we know the polarity of all these components.
Well, now, you know what I've been guilty of recently is with MLCCs going up in value, ceramic capacitors that aren't polarity sensitive. Yeah. Sometimes my footprint still has a dot, and so I've been guilty of having a dot when it's not needed. And to an engineer, you go, well, then don't stuff it. But that means somebody else is going to be going, looking at the dot.
It's a huge red flag. It's a huge red flag, because we see a lot of times customers will, they'll populate their bill of materials, and maybe they need 10 mics or something. They need a lot, but it's only an 0603. And
instead of doing tantalum, they'll grab a ceramic, but they leave a tantalum
vice versa
footprint.
Yeah. Or a lot of times they'll grab a tantalum.
Versa. Yeah, that would suck.
And then so all of a sudden we're populating a board with tantalum capacitors we're populating a board with ceramic capacitors, and there's polarity indicators. We're like, whoa, something's wrong here. There's a problem here. Yeah. And we actually had that happen to us very recently. And we've been training a new person on how to program our pick and place machines, and he just didn't catch, like, oh, there's a polarity indicator and this is a non-polarized part. And so we were in the middle of production when we discovered it. It's the worst when that stuff happens. Like, we try to catch everything before it gets into production, but stuff slips through. It just happens.
Yeah, big problems start with small symptoms. That was your clue. that little asterisk that barely printed was your clue.
Yep.
Something was.
We actually, there's an episode of our podcast where we say it's something about early decisions casting a big shadow on the rest of your product. It happens.
Yeah. Well, the other thing, and I've been guilty of this, I don't tell you all of the DNPs that I put out there.
Yeah.
I made a last minute decision not to stuff C10 or something.
Yeah.
And I forgot to tell my board house, and then I'm not surprised when the phone rings. Yeah.
Yeah. What do you want us to do with C10? Yeah.
C10, that's not on the board. What do you mean C10? Yeah.
We actually analyze all that data before even providing a quote. Like, we'll actually go out and usually what we'll do is, when we will provide the quote, but we'll show you your BOM discrepancies. We're like, but here's basically what it's going to cost us to build it. But if you want us to build it, you got to fix all these things because we don't.
Oh, good.
These are the questions we're going to ask right away. Yeah.
Good, good. So, and that's kind of where I was headed to next is, you know, failures happen. And at some point it's like, well, was it you? Was it me? Was it both of us? What could we have both done to help each other not, you know, even if it is my mistake or your mistake. So we get into
it's
things
such a complex problem. Like circuit boards are so complicated.
Well, where I'm headed is DRCs, right? Design rule checks. So you know, we have DRCs for the board fab process, and that's where you said, you know, 6 mil, 5 mil, that kind of thing. But then there becomes DRCs that are like, well, you're too close to the edge. I don't care. Well, somebody might, right? And that's probably the guy that has to handle your board.
Yeah,
is the way I see it. So,
and the trouble is, like, we always find workarounds to everything. So if something's too close to the edge, we're like, well, we could probably do this and that. We can make it work, and so, you know, you can get away with all that kind of stuff, and you don't realize all the hoops maybe that your manufacturer has to jump through.
Right. So
to get it done.
You owe it to the guy that you did it for to say, by the way, we had to jump through a hoop. You know, on your future boards, you need to.
We usually do. Yeah.
Okay.
We usually do. So, like, for example, recently we had this customer who's putting these big giant, they're like bigger than a D cell battery, these massive batteries on his board. I have no idea what this thing does. It's just a huge battery. But the battery holder is made of some kind of, I don't know, aluminum or tin. I don't know what it's made of. It's metal. And then he's got a through-hole switch on the bottom side, and the battery holder and the through-hole switch are just and it's like, okay, so what are we doing here? Because this is a metal battery holder, and this is a switch. It's going to ground out your switch. You're not going to have a switch. You're just going to have a closed circuit. What are we doing here? And so we had to, like, flush cut everything, capped on tape it, and we're like, okay, we only built 100 of these.
Right. This is not for production. This is so that you didn't throw everything in the trash can. Yeah.
If you do this again, we have got to charge you for cutting all these leads and putting this Kapton tape down, you know?
Well, not to mention with vibration, it could fail later in the product lifetime as it rubs its way through the Kapton
is not. Yeah, Kapton is not.
Same with electrical tape. It's an insulator, not a mechanical separator. Yes. They're two separate things.
It's an insulator, not a mechanical. I love that. That's a very good way of putting it. Yeah.
So
as much as possible, we try to point out, like, manufacturing problems, but, like, sometimes when you're only building 3, and, you know, Bill didn't tell me that he wanted to build 1,000 of these someday. You're like, muscle our way through it, get it out the door. You know, we want to ship on time.
Right.
We never have the conversation.
Making a problem for later. Yeah.
Yeah. We never have the conversation. So it's good. You know, Bill, you know, do some due diligence and go, hey, I plan on building more of these. Did you have any problems when you ran these before? Or, you know, hey, here's the order. Please let me know if you have any manufacturing problems that, you know, I'd like to correct it because I want to go to volume with this. And, you know, just have these conversations about these kinds of things. Yeah.
And as an engineer or layout person, you need to, if you are going to production, start laying out for production from day one. Don't think, well, I'll fix it later. Don't even think that. I mean, in my shop, fix it now because this is the time.
If it's a problem for production, it's probably a problem for prototype too, to be honest. You know, it probably is. Yeah.
Right.
We see, I mean, when you're doing 10 unique jobs a day, we've seen, I mean, every imaginable kind of. My favorite thing we see all the time, and this is, so you were asking about what do you do when something doesn't work, and I wanted to kind of talk about the big picture of what that looks like, because it's circuit boards are so complicated, right? Like we see them every single day. You guys are designing them every single day. It starts to feel like a glass of water. It's like, it's a thing that, you know, does its job. What's so complicated about it? No,
it looks
it's
easy.
So freaking complicated. Like when you really get down to how complicated it is. So when something doesn't work, it's like, oh God, okay. Where do we start? How do we figure out why this isn't working?
And when you see a big board, any little tiny small, in fact, one tiny small broken thing on that means the board's broken. And when I watch those videos of the insertion, my mind reels because I'm going, no, one tiny thing. How's that
Yeah.
work? How's anything work? And then
How's anything work?
and then they find me in the closet crying, with the door shut. It's like,
I totally agree.
I'm
I
straight
totally
on,
agree.
straight up
So
fail.
I'm excited. These new machines. So our existing machine will use a placement force of about 7 newtons. Each part gets 7 newtons. It's a lot of force. It's a lot of force. It's, and because it's trying to stick it into the solder paste, because our existing pick and place machines, they actually move the board. So if the board is not really secure on the solder paste, the part isn't really secure in the solder paste, it might go thung, because it's moving the board the whole time. Our new machine, the board is stationary and the pick and place head is moving around it. It uses half a newton for almost every placement. Larger ones will place with more force, but for almost all your chips and like small devices, half a newton of force. Because there used to be these, well, they still are. I mean, we see them all the time. They're like I don't know what, they're like a glass inductor. Is that even a thing? It looks like you see the wire and it looks like it's encased in glass, like in an 0603 package or an 0402 package. Well, they have terminations on the bottom. So you have, picture a brick that you've set on 2 pieces of 2x4. So you have a cavity in the middle of it. Well, when you're pushing down on a piece of glass with 7 newtons of force, that thing just wants to just break every single time. Right. So, we discovered that and realized we have to use this other, pick and place head to make sure that it's a soft touch and everything.
Well,
so
I would think that happen again. Too much when you squish out the paste. If you displace the paste, if it used a lot of force, or am I misunderstanding it?
Yeah, you do displace the paste a little bit, just a little. Just
you want just a little, but to wet
just
it,
you want just a little. But too much will just blast it out.
Blast out.
So so you could have a cracked capacitor, cracked resistor, cracked inductor, these little tiny devices. You could have a part that was defective from the manufacturer. It happens. Like TI had a bad lot, and we, 1 out of every 10,000 was an issue. Well, guess what? That one board had one of those bad SO8s on it. You could have a lifted lead. You could have a bad solder joint, right? So what we usually do is, like, basically, if you have a problem with a board, and I'm talking about ourselves, and I can guarantee you almost every manufacturer is going to have a very similar response. Don't just just assume that we don't care about that. Like, we do want to know. Like, we would like to help make sure that we don't have these problems, and we'd like, especially if it's an ongoing thing. If you just ordered 100 and you only needed 95, and it's one job's done, well, 1 failed. Okay, maybe you don't care that much. But if it's an ongoing thing, we want to know about the even 1 out of 100. Like that's important.
1%. Yeah,
it's 1%. And at low volume, that's actually kind of a normal percentage. At high volume, it should be 0.00.
1 to 3 for that kind of stuff.
So at low volume, though, if you're talking sub 1,000, 1% is not that unusual. Anyway, so we want to look at it and go, okay, are all the solder joints exactly the way that they should be? Is there sufficient solder? Is there good hole fill? We really want to make sure that what we have control over, we did correctly. And so we'll really we'll take our time and really dig into these things to make sure it's done right. But I'll give you 2 recent circumstances where we are basically, our customers coming to us saying, hey, none of these boards work. It's like, whoa, geez, all right, well, let's figure it out.
Phone call, yeah.
And send them over. Here's our UPS number. Overnight them. We'll take a look at them as soon as they arrive. 2 recent examples, and this is fairly common. Don't get me wrong. We find our own mistakes too. I'm not saying that we don't make mistakes, but 2 recent examples. One, they were flashing their chip with a little, I don't know, something in the code that basically said, don't communicate with the memory.
Right.
It's like, so like, of course nothing worked because this one little bit in there. Yeah. So we're overnighting, spending hundreds, and depending on how many times you do this, thousands of dollars, and ended up as a piece of code that was wrong. We'll do our part to make sure that we didn't do it wrong, and the programmer has to do his part too. And then another recent example, and I can't believe how often I see this, and I totally get how it happens. I totally get how this happens. a mirrored footprint. Like they'll look at the bottom view of a footprint, and then they'll lay out their footprint with a bottom view rather than a top view. And so again, none of these are working. We'll try to figure it out. And then, well, they're all shorted out. You know, this net is shorted to ground. Okay. Well, when we remove this chip, that short goes away. Oh, that's not supposed to happen. All right. Well, oh shoot, I mirrored the footprint, you know? So like
I've never done that. No, not to a SOT 23 package. That you have to turn and flip over to make it work. Yeah. Never.
It happens so many times. Fun fact, SOT 23 can fit in any direction. If you do a footprint right, you can get it to fit.
SOT 23 gives and it takes away both. Yeah.
So if you do your footprint wrong, you can almost certainly
make
rotate
it fit again.
And it will look stupid. It'll look stupid, but it'll work. Yeah.
Right. And actually be mechanically sound. I've had them standing there like this, and you know it doesn't fall off the board and stuff. Yeah. So it's now it's funny you mentioned those two parts shorting together, right? I used to be notorious for not picturing the 3D ramifications of my part, right? All the pads fit together. Well, geez, there's this huge plastic till this one I got to give to the CAD tools. Now in my Altium, my Proteus, whatever, I click on 3D view and I go, holy poop, I was about to make a big mistake. I have to admit the 3D views, I make myself study those. You know,
They are useful. I think even if you're an old school Eagle user, I think the new Fusion has a 3D view on it now too, which you can use with. You can take your board and you can take your Fusion model and you can even get it to see if it fits in the case and everything. But I haven't used it yet.
Oh, here's a good one. Somebody just posted. Because I just went through this with somebody's like, oh, ground VCC, and you have to bring them so close together. And you know what? For the ESD protection diodes for USB, they're sold in 40402. It's hard to find an ESD protection diode that isn't tiny, but yet by definition, you have to bring these two behemoth signals close to each other. I've been known to not stuff those for prototypes. It's like the one area where I'm like, oh, my risk of putting the part on the board if I'm only building 3 is greater than learning later whether I've got the right part.
So I'll say the limit there, because people ask me all the time, how close can I get components to each other? The limit there is really the solder mask thinness. How thin can I lay down a piece of solder mask? Yeah. Because if you can get the solder mask there, the solder won't bridge. But if you don't, I think the limit is a good fab can get down to 0.1 millimeter, but not for a long distance. Not for a long distance. In a short, small distance,
between
it can
two
get down to
pads
0.1 millimeter. Between like a QFN, if you had like a 0.4 millimeter pitch QFN, they can lay down a 0.1 millimeter piece of solder mask. If I don't have solder mask, your board's gonna be a mess. Like there's gonna be bridging everywhere. Every QFN is gonna bridge. You know, your two capacitors next to each other, they're gonna float into each other. You know, it's solder mask is a miracle. It's every assembler's best friend.
And I'm from the days when solder mask would double the board, not double, but it would add to the board cost and add days to the production. So when you look at real old equipment, a lot of times it doesn't have solder mask on it because solder mask was hard. Now you couldn't get a board. To get a board without solder mask, you'd have to produce it with tell it to.
Yeah, you almost got to pay extra.
Because
remove
all the mask for me. Yes.
I can't put that through our normal process. I got to reroute this thing. I need to give you solder mask because I just need it to go through one process. Yeah.
Right.
Yeah.
So now when you go to Sierra Circuits, it's a great place to run a design for manufacturing test of your board. You upload your Gerbers. And one of the things do you want to know about the things we fixed for you? And you go, okay, tell me about it. And you go in and almost always they're going, we added some solder mask for you.
Yep.
We stuck it right in between those two pins that Chris is talking about. Yeah.
Sierra is a great shop. I know the owner over there. They're obviously a direct competitor, but I guess Sierra is technically a fab.
Yeah. Fab. I mean, yeah.
Yeah, and then the owner also owns an assembly shop, but he's a super smart dude. He hires great people. He's yeah, it's a great organization. Anyway, they do it right because they, as an assembler, because they have the partnership with their assembly house, they know you need those solder mask slivers. I can't tell you how many fabs are like, oh, those solder mask slivers are too thin, so we just removed them. Like, no, you can't. I need those.
When you ask them why you removed them, they're like, so they don't fall off.
Yeah.
Right? That's their fear, is that they'll fall off and then clog something later. Yeah.
So we actually had to go to one of our fabs that kept doing this to us, and we said, we need you to be able to lay down a 0.1 millimeter piece of solder mask. That's not going to work. It's never going to work. We're like, well, all of our other fabs are doing it, so it must be possible, you know? And you just sometimes just have to talk to the right person. And eventually we worked our way up the chain to the right person, and they were like, okay, I got to research this. He did some research. He contacted his material supplier. He contacted his equipment supplier, and he figured out like the process flow to get it done. The right material, the right time and temperature and exposure,
he did his
and
job.
all that kind of stuff. And then he's like, okay, I can do it. But he had never been challenged on it before, you know?
Right.
So.
Right. Now, when you're getting real small boards for, well, let's say somebody comes to you for a run of 3 to 5, you would prefer them to be panelized, I assume?
I would prefer you let us order them as well, because we will panelize them. We will panelize them exactly the way we want them. And because we have a very automated assembly process, we want them very specifically panelized. If you come to us with a panel, we will probably put that panel within another panel because we have a very optimized workflow that has to be just so.
So just as you don't want me bringing you my box of parts, you don't want me bringing a box of PC boards either. You want to order the boards yourself.
That's right. We might say yes, but we don't absolutely say yes. Like if you have hassle finished, we probably will just not even bother. We're like, nope. If they're hassle finished, unless they're like, I mean, if you're not doing fine pitch, right? If it's if it's like 0.5 millimeter, that's borderline of where I want to be okay with a hassle finish. If it's anything BGA QFN, nope. I will not touch a hassle finished. Yeah, will not touch it. Like it's possible. You can do it. You can do it. Totally doable. I don't want to do it. And I can't charge you enough to do it.
Right.
You know.
So hassle is hot air surface level. It's basically solder already on the PC board.
Oh, sorry. Yeah.
Yeah. So it's like, well, there's solder and it's not going to be level. It's only hot air, whatever level is, and then paste on that. And that sounds like a big mess to me. So yeah.
Yep. And it's just, I'm going to bridging everywhere. It's just a big mess. I mean, if it's all 0603 and 0.65 millimeter pitch and bigger, fine. You know, it's going to be fine. But the other risky thing is we don't do any lead, none, zero.
Really?
Okay. I take that back. We have like one friend of the owner who like convinces the owner to like, well, can't you just do this lead for me? And so we get like, we have to special order solder paste for his job, and we only do the surface mount. We don't do any of the through hole for him. But anyway, but then if a Hasselboard comes in, we go, well, how can I know that this is lead-free Hassel? Like, is this definitely lead-free Hassel? Am I going to contaminate my equipment with, you know, a lead board here? So that's the other reason we don't want Hasselboards. We don't want
I never even thought of that. Yeah.
We don't want a contamination risk. So we do pretty much everything ENIG, which is electro nickel-less immersion gold.
Something. Yeah.
And it's basically like flat as glass, man. That is just so flat. It's fantastic stuff. Yeah.
Have you ever dealt with the fancier ones like organic and any of those?
Mm-hmm. Yeah. So OSP is great stuff for volume. You really you need to nail
Control
your process.
Yeah.
It's really not forgiving at all. It's not forgiving. Like you've got to, you know, the way I like to use the illustration of like an archer. You know, your archer has a target, and ENIG's target is this big, and OSP's target's this big. Like you can hit it, but you got to have really tight control over your process to hit it. But it's so low cost.
Well, and it's so hitting it reliably. Isn't the problem with organic that if you don't understand how you managed your boards, you won't understand where the failure came from.
Yeah, you gotta manage the boards properly. There's moisture issues with them. Yeah,
Handling,
and so a lot of
handling,
times you have to
handling,
bake
handling,
them. Yeah, so
touching.
they're just
Right.
not forgiving, not
Right.
forgiving. But they're like every consumer electronics is OSP, like all of them. Because it's just so cheap, and because if you're doing tens of thousands, like that process is gonna be nailed. Like
Right. Right. If
you're not gonna change a thing about it. Yeah.
right. Right. So how do you, so if you say, I want to buy my own PC boards, or I want to buy your PC boards for you, how do you compete then with or can you compete with the overseas sources? Like before the show, we were talking about, PCBWay and JLC
Yeah.
PCB. Um, and people use those because they're cheap and they're used to working with them.
Yep.
Are you competitive with that process? Because in the old days,
So
it cost thousands of dollars to get a PC board.
yeah, yeah. It's the dirty truth is we're ordering from China a lot of times as well. It
Okay.
depends on your comfort level. You may have Bill's inventing the next great iPhone, so he doesn't want any of his IP to leave Massachusetts, and so we'll find a fab in Massachusetts. Well, actually, I don't think there's any left in Massachusetts, but we'll find an American one possibly. Versus, I'm just making these Formula One temperature sensors. I don't care. Yeah, get them from China. So
Right.
a lot of times we order a lot from Taiwan and China because and the truth is the best fabs in the world are in Taiwan and China. The best
Right.
like
Right.
the highest technology, the latest and greatest specs. It's all coming out of China and Taiwan.
Now, if I gave you my Gerbers and you knew you were going to go somewhere, whether America or China, do you guys then take the Gerbers, throw them in a Gerber viewer and pour over them, or do
Oh,
you rely
100%.
on?
Yeah.
Yeah.
Yeah, 100%. Now we do rely on the fab. Well,
Well,
there's
the
a bit of
fab
a
will tell
mix.
you if you miss something, I assume. Yeah.
Yes, yeah, but and because we have a partnership with them, they know what we want, right? So like we've been working with them for 10 years, so they know not to remove the solder mask slivers. They know they know we need those solder mask slivers. It's stuff like that. They know that we want them to correct your silk screen so that it's legible. They'll literally go in and they'll change your line thicknesses and they'll move and they'll bump around your R36s and they'll get everything to fit.
Oh,
You
get them
know,
off the bare
um,
copper, that kind of thing.
yep. They'll ask us, do you want tented vias? This customer didn't tent any of their vias, and then we'll go back to the customer and be like, hey, are you okay? Because we like, if possible, if it doesn't affect your design, we like to cover the vias.
Sure. Sure.
Just from a visual perspective, it's much easier to see if we made a mistake because all of the via, like when you look at the vias and you see all that gold, they look like open solder joints. Looks like we missed something, right?
Right.
When they're all covered, then we know we didn't miss anything. So,
And to
if
an
possible,
engineer, although that gold looks like, oh, look at all those test points I can
test
use
points,
for
yeah.
debugging. Yeah.
Yeah, exactly. If you want test points, 0.8 millimeter rounds, perfect. Just put them where you
Really?
need them.
Okay,
0.8
I'm
millimeter.
writing that one down because
Yeah.
I lately I've seen some different ones in the libraries that come with CAD.
0.8 millimeter is sort of like the sweet spot of like it's big enough for all bed of nails testing, but it's small enough that you can usually kind of fit it almost anywhere.
Right.
But there's designs that tented vias are not okay. Like there's customers say, no, this is gonna have an impact on my product's functionality. Do not tent my vias. So yeah, I'm not saying it has to be done. It's just a convenience for us, honestly.
Right, right. Well,
Yeah.
there was a day when, now I control tenting in my CAD system. But there was a day in the past where we had
You
to
had to do it
tell
yourself.
tenting was you told somebody, you just like
Yeah.
you said. Yeah,
Yeah.
it was a
Somebody,
okay,
vias
ahead.
always spark huge discussions, always. And I'm looking at the chat room, always, every time we talk about them. So they suck solder paste away from the pads. Yeah, perfect. But you got to make sure you have solder mask between the pad and the via, right? Don't put the via so it's connected to the pad. That's the key. You can have it untented, but you got to have a solder mask sliver in between it so it doesn't run into it. We have a lot of customers that do like tons and tons and tons of these QFNs now. They put like a big thermal heat sink underneath the QFN, and so you have tons of vias all over the pad. And we don't touch those. That's obvious at this point. We know, like, yeah, you're using that to draw heat away.
Right.
You want the solder paste to fill those. Like, no duh. Like, we get it. You don't have to tell us not to tent those. but we've seen a lot of like 0805s and 0603s where they put the via right in the pad, and it just sucks all the solder paste away. And we're like, do you want us to plug? Do you want us to have the fab plug and plate these? It's going to be extra. No, it's fine. I'm like, you're not going to have any solder on
No,
there. Well, then add solder. It's going to be more expensive for me to add solder than it is to plug and plate the via.
yeah, yeah.
Yeah.
So you do that's HDI and stuff. You guys do that?
Oh yeah, yeah.
And do you have an X-ray machine?
We have an X-ray machine. That's about all I want to talk about that. So,
Okay.
No, we have an old X-ray. What's ended up happening was sort of like we talk about process control, right? We're having such high success rate on our leadless components, and it's like, what, we can't justify the expense. Nobody has come to us and said, hey, here's 20,000 boards back because you effed them up. And now I'm hanging on to $100,000 bill because I can't charge my customer for boards that don't work.
Right.
That's never happened to us, which would justify an X-ray expense, right? Oh my God, the house is on fire. We better, call the fire department. We've also never had a customer come to us and dictated like, you must 100% X-ray every single job. So we've just never had an ROI for it. You'll find that's quite common in small shops like us. It's getting less common because the cost of X-rays are coming down. It used to be you'd had to spend $200,000-$300,000 on something that doesn't make anything. Right? An X-ray doesn't make anything. A pick and place machine makes something. A refill oven makes something. A stencil printer makes something. You're making money with those things. An X-ray doesn't make anything. You're just verifying that what you did is right. So yeah, and because we've had such high success rate, we've just never had to do it. If we've ever had an issue, we do have. I've been in this industry for a long time, so I know a lot of people with X-rays, and I'll hire them, pay them $500, do a thorough X-ray on it. So the few customers that have mandated, like, you must X-ray every one of my BGAs and look for voiding, yada yada yada, we say no problem. We'll use a third party to do that.
Oh, okay.
So we build them, assemble them, send them to a third party, get the whole report back, and they'll drop ship to our customer, right? So they'll drop ship, but we'll have the report and everything. It's all totally disclosed and not hiding who it is or anything.
Right.
So
interesting. Yeah, I hadn't thought about that.
It's like if I had a $150,000 X-ray, because that's really like the one you want is $150,000. You don't want to buy what we have. What we have is like $10,000. It's just to see if is there a big giant short on this BGA? It's about all we can tell. But you need the slicing ones. You need the slicing ones. You need the ones that can cut up the board so you can separate the top from the bottom,
Right. I looked at them as a troubleshooting tool for really tweaking a process that boggles my mind to begin with, right?
Yeah.
That's
and we're happy to, like, if you are having a failure 100 out of 100, or well, honestly, even if you had
10 out of 100.
If I have 10 out of 100 and you think and you suspect it might be the BGA, we're happy to, go to this third party, have them do the work for us, get the reports, we'll pay for that, because we don't want to be responsible for 10% failure rate,
Right. So, well, it's already been almost an hour and a half. Can you believe it? And
this is trouble. I could talk forever.
Well, so can I. So final topic, and you and I were talking about this before the show here, is testing. And,
yeah. Great one.
Yeah. So and people should know about that. So your big test is an optical test. I've heard you say AOI and stuff.
Yeah.
Tell us about like optical testing and teaching it and how it works.
So actually, I was that's kind of probably something I know more about than anything else. Out of college, I went to work for an optical inspection company, a startup out of California, and shocking, out of California, right? But I learned a lot about the technology and the vision systems, and it's gone way beyond everything I learned about that first job, that first startup. It's so much more advanced, and now like with OpenCV, or OpenCV computer vision, right? it's like leapfrogged all these industrial suppliers of vision software and everything. So it's just gone crazy. But AOI, basically, you take images of a finished board that you know is good. So we have a verification process to verify that this board is absolutely, we know this is correct. And then you program the machine to make sure every subsequent board looks like that. Unfortunately, it's not as simple as just taking a picture and comparing a picture.
Right.
There's so much nuance to it. The coolest new ones, we actually have a whole episode all about 3D AOI on our podcast. But the coolest new ones, they do this height mapping now. So what they do is they use tomosynthesis height mapping.
Okay.
It was invented, I believe it was invented in Korea. And what they do is they basically take a projector, just like a projector that you would project a movie or whatever else.
And they try and discern the height from little cues like parallax and stuff like that.
Exactly. So they do a zebra stripe on it, just tons of black, white,
Structured
black, white.
Yeah.
And then they look for the breakup in the pattern, and then they measure the length of the shadows and things like that, and they can figure out the height of everything, and they hit it from all kinds of directions and everything. And so now we can actually measure like the slope and angle and volume and fill of solder joints, even down to 0201 or 01005. And it's like mind blowing. And if I screwed up a BGA, like if I didn't have full collapse and reflow on a BGA, I can see that.
Oh, really? So it's a 3D
yeah.
inspect. Yeah. Wow.
So if I have a 0201 stuck under there, I'll see it's sitting up in the board,
Right.
We have gotten to the point now, this technology has gotten so good that we can confidently ship boards straight out of this machine without going through a human inspector. I could not have said that a couple years ago. The technology just was not there yet.
Right.
Because what we did is we did an evaluation after we introduced this, and we got to the point where we said, okay, everything goes through 3D AOI, then everything goes through visual inspection. Visual inspectors, what are you catching that this machine is not catching? And after like 3 months, the spreadsheet was dry. There's nothing in it. And so we're like, oh, well, this is a no-brainer. It's pretty cool.
And I was going to ask, where you got your Z information from, because I'm thinking of flying probes and you don't want them to hit tall components. But you're saying, oh, we figured that out. I don't need Z information from you, Bill, though I'll take it if you have it. But we can figure it out also from the optical system, it sounds like.
I wish that were true. There's no exports. There's no exports.
Sounds good.
Yeah, you can't export it. Yeah. But I hope somebody's working on that, because a lot of times these flying probe companies and these AOI companies, they complement each other. I wouldn't be surprised if we see a partnership and the two of them work on that. I wouldn't be surprised if that happens. Yeah.
Right. I totally agree. To me, it's not one or the other. They're complementary technology.
Oh, they're complementary. Yeah.
Yeah.
So we don't have flying probe in house only because most of our jobs are 3.5 boards, right? There's just flying probe doesn't have a lot of a justification for that volume. We do a lot of functional testing. So that'll be where, Bill has designed his Arduino, and he's got like a ribbon cable that we plug into it that's connected to a Windows computer, and we verify that, it flips this relay and this voltage is correct and blah, 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 and all that kind of stuff. This light comes on when it should, and this, the display is reading out, like a literal functional test. And we've seen everything from really inexpensively made with like a Glowforge, plastic cutout kind of a thing with a couple bed of nails, to partnering with a company that literally, this is all they do is make a functional bed of nails tester with like a proper clamp, and and that's where I got that 0.8 millimeter spec from. They told me, they go 0.8 millimeters, just put 0.8 millimeter test points, you'll be golden. We can do anything we need with 0.8 millimeter test points.
Right. Cool. Yeah, I completely ruined I had Altium scratching their head. Somehow I redefined the library, a pad in the SMT library, to be a test point. And suddenly all my SMT devices had test points for leads instead of pads. And I had to go back to a previous version. Altium couldn't undo whatever I had done.
The trouble with those reference libraries, man.
Yeah.
They pointed at each other and
Oh yeah, yeah. Picture everybody walk around in their shoes with the toes cut off and their toes sticking out. That's what all these test points look like, hanging out of everywhere. It was ugly. It was scary and ugly
That's
both.
pretty funny, actually. That's very funny.
Oh,
I can imagine
right,
fabbing a board like that. Like, what the hell is going on?
right. So, so real quick, so I can keep talking
Mhm.
too here. Um, you talk about optical and catching, you know, where the BGA hasn't sunk and stuff. And of course, one of the early things you learn about is tombstoning. And
Yeah,
that sounds easy to catch for your systems
yeah,
these days, right? Because
yeah.
it is a Z. It doesn't
Oh, it's
look
super
like a,
easy. Yeah.
yeah.
But it's also super easy to eliminate. Like tombstoning was
Tell us
more of an
about that.
issue.
Yeah.
Yeah. So if listeners aren't familiar with tombstoning, basically rather than a capacitor sitting on both pads, it sits on just one and it stands right up just like a
Surface
tombstone in the
tension holds
cemetery.
it up in the air. Yeah.
Yeah.
Or off
So
to the side.
that was way more of an issue in the lead days. Lead had this weird quality about it that it would, it would just, I don't know all the science behind it, but it was just more prevalent in lead. And also it was more prevalent in larger components like 0603s and stuff. It was more of an issue. As they've gotten smaller, tombstoning has become less of an issue. The other thing is the SAC 305 alloy, which is the most common lead-free alloy that pretty much like everybody uses now. There's a couple other varieties used for through-hole. Through-hole has a different alloys
Right.
that are more popular than SAC 305, but SAC 305 for surface mount, super popular, has less of an issue with it. Then on top of that, the chemistries are much better than they used to be. So the companies making the solder paste, they're designing solder paste to eliminate tombstoning. Like that is a feature in the data sheet. The
Right.
solder paste
Right.
eliminates tombstoning.
Right.
Also, we've learned a lot about stencil design in the past 20 years to eliminate tombstoning, and how you design a stencil appropriately, to make sure that this effect doesn't happen. And then on top of that, the most popular piece of content I've ever produced in my entire life was a blog post on our website called the Perfect 0402, and then I had a subsequent one, the Perfect 0201 footprint, because we found we had this one customer who we never ever had tombstoning issues, even back in the lead days with his 0402s. Never, not one tombstone ever. And I go, Kyle,
How'd you do that?
can I just take your footprint and publish it? Like, do you mind if I just take your dimensions and everything and just publish it? He's like, yeah, I don't care. He's like, I think I got it off of some Panasonic data sheet 20 years ago. I'm like, perfect. And inevitably, I have not once have I ever had a customer use that footprint, and I've had a tombstone, and not once have I ever had a tombstone that that did not have some kind of a footprint related cause. It's always footprint related at this point, because now with the SAC 305 alloy, with the chemistries so much better, with the stencil design so much better, and the stencils themselves are so much better, it's always layout now. It's 100% of the time.
Well, I was going to say I'm used to being the blame for tombstoning is because I didn't picture that how much heat is needed on each end, and if they're unbalanced, how much surface area, how much
ancient history. That's ancient history. That's no longer a thing. That's totally not even. You never have to worry about that again. You can have a 6 mil on one side and a ground plane on the other. And if you get this footprint right, you will not have a tombstone. I guarantee it.
So how'd they fix the stencil for that? I mean, I'm used to thinking of a stencil as the pad plus a certain amount, right?
Yeah. So minus a certain amount actually.
Yeah.
Yeah. So we change everything about your solder paste data that you give us. Which absolutely nothing is the same when we're done with it. We're hitting IPC targets of volume and process and everything. We're not changing that. We're still going to ship it to IPC class 2 or 3, but we use something, and a lot of shops do this now. I think we were one of the very first users to do this. We use something called a 1/3 U shape. So if you have a rectangular pad, or let's just say a square pad, and sorry if there's people that listen to this and can't see me, but let's say we're using a rectangular pad, and you have a rectangular pad here, and then you have your rectangular pad here. So you left and right. On the inside of the left one, we will leave a little tongue on the stencil. and on the inside of the right one, same. We'll leave a little tongue on the stencil. So you create this like U shape, this U pattern that you print, and it's only 1/3. So you have 1/3 solder paste, 1/3 stencil, 1/3 solder paste, and then on the back 2/3, it's all solder paste. Eliminating that little thing there
Right.
has eliminated tombstoning largely. That was a side benefit, honestly. The biggest thing it did is it eliminated what we sometimes call mid-chip balling or solder balls, where you get a little piece of solder ball that'll just go boom in the reflow oven and just go flying out. Because now there's a place for the solder paste to fall into underneath the chip. Yeah. Right. Whereas before it couldn't escape, and so it was just like a pressure cooker, and it would just go boom. It would just go out. So that eliminated mid-chip balling, but we also found as a side benefit. That's why we did it, was mid-chip balling. But we found as a side benefit, it eliminated tombstoning as well. Like even jobs that had tombstoning issues, we could mitigate with this 1/3 U shape. But that there's a limit to it. Eventually, you get to a point where it actually makes tombstoning worse. So
yeah. That's so interesting. I didn't think about things like tombstoning, and when I say tombstoning, I also think of other the production oven problems. I never thought about fixing it in the footprint. To me, it was always about how I abused it.
Yeah, I guarantee you. So I think the magic number, I gotta. It's so funny. This site, I always look up the stats on this thing. It's perfect 0402 footprint. This page on our website gets thousands of hits every single month. Thousands of hits. We do not have thousands of customers, but we have thousands of people looking this up. The magic number here is in an 0402, the magic number to make this perfect is the inside pads need to be 0.4 millimeters from each other. No more, no less. 0.4 millimeters. If you, like, I don't care how big everything is around it, if you can get those inside pads 0.4 millimeters from each other, you will not have any tombstoning.
Wow.
So this, I'm talking about the cathode and the anode side, getting those two, 0.4 millimeters, the leading edge, the inside edge, 0.4 millimeters from each other. That's the magic number there.
Okay. Hang on a second. I think I might be able to, whoops, not a slide, share screen, window, boink. There's your website.
Hey,
right?
There it is. Yep.
Okay, force me to use my glasses here.
Yeah. Oh my God, I made that video such a long time ago.
So this is on worthingtonassembly.com. I found it by Googling Worthington and 0402 footprint.
Yeah.
For those that want to find this, this is very cool. The perfect 0402 footprint.
Yeah. Yeah. What did I use? I think I used paint to draw that.
Hey, I think we used paint to make chips in the old days. I mean, it was so archaic compared to these days.
Yeah.
So tell us about your podcast. Let's as a way to wrap up here. How can people hear more of this and more of you?
Just like you have a podcast app, just type in pick place podcast. It'll come right up. We did it because we used to love to give tours of our factory, and we would educate designers and stuff and talk about like, here, this is what it takes to get something built, and this is how you have an impact on things, And then during don't knock paint, never knock paint. Then during COVID, we couldn't do tours anymore. Right. And I was talking to our marketing director, and I'm like, we got to do something. So she's like, well, we both love podcasts. Let's start a podcast. And so the whole shtick of it is, like pulling back the curtain on the manufacturing process. Like what the heck is going on behind these doors? What is stencil printing? What is a pick and place machine? How does it work? How do you use a pick and place machine? Like when I walk up to a machine, what am I looking at? What is a feeder? Like really breaking it down. What is solder paste? What is flux? How does flux do its job? And how do we use it? How do we effectively, make it do what it needs to do? So, I love it and hate it. I hate it because it requires so much time and energy and thought. Like, and I really want it to be good. I really, really want it to be good. So I don't just roll up and just start talking. Like I try to like, and I hate it because I hate doing that kind of stuff. I hate like putting together an outline and doing research and making sure all this stuff is right. But I love it because I love talking about this stuff. Clearly, I mean, I don't think it's any surprise to anybody who's listening, but I love it because I feel like this content doesn't exist. Like it literally outside of the four walls of a manufacturing plant, nobody knows half this stuff. And so finally it's getting documented in an audible form, which I would prefer if it was more of a visual form. But you know, these there's just not enough of it. There's some great resources like you mentioned. Sierra has great resources. They publish a lot of nice blog posts and stuff.
Yep.
There's Worth does too. WURTH, the German company.
Right.
They publish a lot of good stuff. But I don't know if it's ADHD. I don't know what it is. I have a tough time like sitting down and like reading this stuff. I'm much better at like hearing it or watching it on YouTube or something like that. And so I hope that the medium does well to help educate designers, especially I'd like to think it's especially valuable for young or new designers, you know, who are, you know, kind of junior level or to
making that
working their way
leap
towards
from a maker
level.
to, hey, maybe I can do this.
Yeah.
Maybe I can do more of this or more, you know, better of this, bigger of this.
Yeah, exactly. So, yeah. And somebody's saying, why not start a YouTube channel? I've wanted to, but it's so much harder. It's so much like it takes so much more work to do the video. You know what I mean? Like to have visuals and okay, I got to capture video, or I've got to have an illustration, or I've got to have a drawing or a picture.
I did videos for Hackaday, and I'll tell you, it takes about an hour and a half per minute. You know, and if you talk with Alan Wolke and people, absolutely, a 10-minute video is 10 hours. You know, by the time you get all of your stuff,
I already complained about how much time it takes to prepare for the Pick Place podcast.
I got Hackaday videos. They're 15 minutes, and I've got 45 hours in them. Yeah.
Oh,
of course, I'm building stuff sometimes too, and I would have several in the pipeline. But by the time I show them something, I've got something I could charge people thousands of dollars for in engineering work. You know, just sheer number of hours.
What we want to do is we want to produce like. Maybe not an ongoing series the way that the podcast is. The podcast is an ongoing series. There's kind of no end in sight.
But hopefully produce a library of like a fact forum or something.
I would love to do like maybe 10 YouTube videos. You know what I mean? Like here's the stencil printer video. Here's the pick and place video. Here's the solder paste video. That kind of thing. Maybe I could do some. Maybe I could afford to do something like that. We get stretched so thin. You know, we're getting these new pick and place machines. I'm going to be
tweaking it.
Gone. My wife's not going to know where I am for months because I introduced these machines to our factory. We're a small company, so it's not like I can just be like, here, people, do this for me.
Make it.
Make it so. No, I have to get my butt down there and like I literally pallet jack these things into place and like that's what you got to do. Yeah.
Well, I've often, I'm a small business owner, and one day I finally understood why a lot of business owners and founders and small company people say chief bottle washer. If you don't do it, it's not getting done, right? So I understand now. I'm the bottle washer for MCG.
And it's in my opinion, my wife and I talk about this a lot. The best bosses we've ever had in our careers did our job before we did it. Right. They or at least, maybe, okay, so I'm not a great like people manager. Like I like people, but I have a tough time dealing with people who don't work well.
You can't fix them like you can a solder paste problem. Yeah.
People throw it out and put a new one in.
You need to change your room temperature.
But so but some people are excellent people managers, right? And they're really, really good at getting people motivated and helping people who aren't performing well. And like those people are really, really good. The best people are the ones that have that skill, but also did the technical thing that you're trying to do. those are the best managers. And I like to keep working on the floor as much as possible, because if I'm trying to motivate a team and bring on new people and help people to be their best performers, it helps if I've done it, to be able to speak the language, so to speak. I'm not going to be the expert. They're going to know more than me, but at least I can speak that language, and at least I know the pain they're going through. So I do like to get dirty and all that stuff. Yeah. Be a bottle washer. Yeah.
Right. And so when you have expectations, they're well-earned expectations of your people.
Right. That's part of it. Yeah, absolutely. Yep.
Yeah. So very cool. Very cool. Well, Chris, I really appreciate your time here today. This has been fun. It's an hour and 45 minutes. I told you that happened too.
Yeah, it does. Yeah.
It goes
I got my wife in the she's I can see my pool through my office window here, and I see her like bouncing around and enjoying herself, and I'm like, it's a nice day out. I think I got to get out there.
Yeah, and I'm headed back to the bench that's behind me when I'm done. But yeah,
perfect,
excellent. So, and we hit a lot of the topics. So if I showed up with my own paste screen, you'd probably throw me out the door. You would tell me you'd make your own. I've learned that.
Probably. I probably couldn't even use it. Literally, I probably would not even be able to use it. Yeah.
Yeah.
Wouldn't fit in my machine. Yeah.
I get the 480 millimeter square ones, the 23 inches, but yeah, no, I get it now. You want to control that aspect of the process.
Yeah.
Rather than have, and see, I guess I'm still enough of a holdover that I still think of small assembly houses as hand assembling small batches. Also, they're just better at it than me, and waiting till 10 or 20 to do and you're saying no.
Bill, the parts
you
are
can't
just
even place
now.
some of those parts.
They're just too small. You can't do it anymore. Yeah.
I mean,
like for the prototype stuff, nobody's prototyping 0805 and stuff. It's all just tiny stuff. Everything's just so tiny now. Yeah. Right. And if it's not tiny, it's usually thousands. And it's like, well, then I'm going to use a machine, like thousands of placements. It's a big board, but it's packed, it's full of stuff. I'm going to use a machine.
Right. Yeah. Right. Excellent. Well, Chris, we got to have you back on again someday, maybe. I mean, maybe at a time when Ben could join us, because he knows way more about this stuff than I do.
And vice versa. So Ben's been on our show. Bill, the invitation's open anytime if you want to come on the Pick Place podcast. We'd love to have you.
Oh, yeah, I can come on and tell you how to make mistakes times millions.
Perfect. That's what we need to hear about. Yeah, I want to know about that $250,000 mistake. That would be a good episode.
Again, that was I ended up ahead $250,000 by the end of the week. So I had a good week that started with me going, yeah, I made a mistake. So what?
We'll title the episode "How to Lose and Then Not Lose $250,000."
$250,000. Yeah. And I was 24 at the time. I don't know that I knew the value of the money. I just knew that, we can overcome. So
yeah.
Excellent. Man. Well, great speaking with you. Go jump in your pool and have a good weekend. And to everybody out there, have a good and a safe weekend. And we'll see you here next week.